My name is Tim Sander. I'm the Vice President of Operations. Today we're going to talk about lifting and handling for precast concrete. Every day, precast concrete structures are lifted, transported, stored, and installed on both in plants and on job sites across the country. So today we're going to cover the proper ways to lift and handle that precast concrete, as well as some of the problems that can arise from improper handling and lifting. So the anchors that we use in most of our structures are utility anchors. Other manufacturers may call them A anchors, but they're designed as an engineered system. You have the anchor and you have the recess former. The recess former is going to create a specific opening in that concrete that's going to allow your hook or your other connection point to connect to the precast anchor. So these anchors are specifically placed with certain criteria in mind. One of the most important is equally spacing those anchors about the center of gravity of the finished piece. If there's a structure that's going to have a large hole in one corner, we shift those precast anchors so that when the piece is lifted, it's going to lift nice and level instead of lopsided. Okay, I want to talk a little bit about the best ways to connect to them in the field. Again, this is a utility style anchor. It's embedded into the concrete here for a 4-point pick. You'll typically have a recess former. The ones embedded in this one are single-use plastic ones. These are some reusable ones, but essentially they create the void in the concrete where you're going to be able to pass your hook through. One common mistake that we see with people who aren't used to lifting precast, many crane companies carry shackles to rig onto a variety of the pieces that they're going to be lifting. Common shackles for the capacity of the anchor do not fit into the recess formers. So what does fit really well, this is a Gunnebo brand, but Crosby makes these as well. Self-locking hooks. This is the 1/2 inch 13 size, which is rated equal for the anchors that we use in these. So these can easily pass in and rig on, and they self-lock. So a really good connection point for this style of anchor is this 1/2 inch 13 self-locking hook. All right, another common lifting anchor that we use frequently here is called a lift pin anchor. These are commonly referred to dog bone anchors because they kind of look like a dog bone. Same principle here. A recess former goes over it and it's going to get cast into the concrete. These lift pin anchors actually have a specific lifting clutch that is engineered to lift them. So the clutch looks something like this for this size lift pin. To connect with that, you're going to find the grooved section there. You're going to place it over the anchor, rotate it, and one very important thing is this tab is a self-locking tab that keeps it from disconnecting. You want that tab to be pointed in the direction of the pull as it would be here. Very nice, convenient anchor to have if you have these lifting clutches. Really easy to engage and disengage the anchor. These are really good versatile anchors. So every one of these structures is designed with specific lift points depending on the weight of the structure and different reasons for those anchors. One of the key things I want to illustrate here is to make sure you're using the proper slings or lifting chains for those anchors. Are designed for a maximum of a 60-degree sling angle. So one of the easiest ways to determine that, both on site and here in the plant, is to measure the distance between the anchors themselves. So we have 12 feet anchor to anchor. So one of the easiest ways to make sure that you're not going to violate that 60-degree sling angle rule is by using slings that are at least 12 feet long, like these are here. So we're going to go ahead and hoist up on this. Another important note is having a tagline operator when you have a long piece that's difficult to control otherwise. And when we lift, we're going to lift in one smooth motion. We're not going to jerk on it or have any rough handling with it. All right, so as you can see, the piece is lifted nice and level. The anchors are placed about the center of gravity properly, and that's going to be really important for the people installing this structure.
Okay, so this is an example that we had in the field. We were contacted by a customer. We've lifted this structure at this point 4 times between stripping it out of the building, bringing it to the yard, staging it for shipping, and then loading it on the truck. So we were contacted. I would assume that they're maybe not as accustomed to handling large structures like this, but they were told the structure broke when they picked it up. So we were looking at it and we can immediately tell that the sling angle was too short for this structure. Right here where the anchor is, if you followed through this point that shows where the chain made initial contact of that structure, you can see a pretty steep angle there. Here to here was your initial pull of those chains. This is taken at an angle, so it's not going to look as extreme here in this situation because this is tilted over as well. Now the distance between anchors here, right here, you have about 8 foot here, and here they're about 2 foot down. These engineered anchors, the data sheets for them will tell you that you should not violate the 60-degree rule. So you should not have a sling angle that is tighter than 60 degrees. When you start doing that, you start putting more force on these anchors than they are intended for. You could start side loading them. You start overloading your slings at that point. And if the chains are also pulling in on the structure, you start introducing forces on that structure that it was not designed to withstand. So in this situation, I believe we were dealing with slings that were 7 foot. Normally, even if those chains were pulling from the inside of this structure, you would need at least the spacing between anchors to be 7 foot for you to have a 60-degree sling angle there. Automatically, if 7 foot slings were used, then we were violating it because you would have to have 8 foot slings there to keep 60 degrees. However, with these anchors being 2 foot down, you have to take away 2 feet from these chains, so you're left with 5 foot of chain that was essentially making your sling angle here. By the time those slings were actually pulling in, you had a much steeper sling angle there. Just doing the math on that, if you did have 7 foot slings here, we made that lift, you would be a little bit steeper than a 30-degree angle. So the load factor on that 30-degree angle, you're basically doubling the amount of force that you're putting on those slings, on the anchor here, and forces that you're applying to this structure right here. That's what caused the failure here. So sling angle is very important. Maintain that 60-degree sling angle. For this structure, we're actually lifting here in the plant with 12-foot slings, but they are adjustable. So if we had smaller structures and we needed more hook height, we could adjust those up, always staying cognizant of that 60-degree sling angle.
All right, thank you for tuning in. Please be sure to like, subscribe, and comment. And if you have any suggestions for future episodes of this, be sure to shoot them over to us. Thank you.